Hello and welcome back to Mr. Butler Maths. In this video we are looking at finding the lowest common multiple and highest common factor using factor trees. I'm going to start by demonstrating what the lowest common multiple is and what the highest common factor is, and then I'm going to move on to demonstrating how we find this using factor trees. So to find the lowest common multiple of, for example, 6 and 8, we would list all of the multiples of 6, that's the 6 times table, 6, 12, 18, 24. Then we would list all the multiples of 8, 8, 16, 24, 32. I could do more, I'm not going to, because I've already found a common multiple and that is 24. Therefore, 24 is the lowest common multiple, sometimes we call it just the LCM, of 6 and 8. Now to find the highest common factor of two numbers, I need to find the factors of both numbers and then find which of those is the highest common factor. So to find the factors of a number, one method that I like to use is the T method. So I draw my T, that's in blue there, and then I write in the factors. I always start at the bottom because 1 is a factor of every number. So 1 times 6 gives me 6. And then I'm going to work up, so 2 is also a factor of 6, and 2 times 3 is 6. Now for my factors of 8, I'm going to start with 1 because I always start at the bottom. 1 times 8 gives me 8. Next one up, I'm going to go with 2 because 8 is even, therefore it can be divided by 2. 2 times 4 gives me 8, so it's 4 is the other factor. I can now look through and identify any common factors. I can see that 1 and 2 are both factors of 6 and 8, and 2 is higher, so 2 is the highest common factor of 6 and 8. So the methods that I've shown here are very helpful when we're dealing with smaller numbers like 6 and 8. However, it does get trickier with bigger numbers, and that's where factor trees can be very helpful. I'm going to start by providing an example of how to break a number down into its prime factors using factor trees. And then I'm going to show you how we can use this method to find the lowest common multiple and the highest common factor. So when I'm breaking a number down into its prime factors, I'm trying to find two numbers that multiply together to give us that number. So with 6, I can split it into 2 and 3, both of which are prime numbers, and that works because 2 times 3 gives us 6. I'm now going to give two examples of where students sometimes make mistakes with factor trees. In this second one, this student has made the mistake of breaking 6 down into two numbers that add together to make 6, rather than the correct way to do it, which is two numbers that multiply together to give us 6. So it is incorrect to split 6 into 1 and 5 because 1 times 5 gives us 5, not 6. Another mistake that students make is they try and break a number down to take off a branch of 1, the number 1. Although this isn't technically wrong, it's not helpful because in the bottom branch we still have 1 and 6. So we're exactly where we started with, and we have to break 6 down further because 6 is still not a prime number, where we could have just broken 6 down into 2 and 3. I'm now going to move on to some examples of finding the lowest common multiple and highest common factor using this method. So my first step, as we've just seen, is to break each number down into its prime factors. I've put a little list of prime numbers on the left hand side. There are actually an infinite number of prime numbers, but I've only included the first few because those are the only ones we're going to need for the numbers that we're dealing with today. 10 is an even number, so I know it can be divided by 2, and 2 is one of our prime numbers, so we want to put 2 off to one side, and we also know that 2 times 5 gives us 10, so 5 will be our other branch. 5 and 2 are both prime numbers, so they can't be split down any further. I'm going to put a ring around 2 and 5, just to make it clear that these are prime numbers. They're the end of the branches. We're now going to split 4 down into its prime factors, because in this case we're finding the lowest common multiple and highest common factor of 10 and 4. So 4 I can split into 2 and 2. 2 is a prime number, so I'm going to circle both of those 2's. So as a product of its prime factors, I could write 10 is equal to 2 times 5, and I could write 4 is equal to 2 times 2. Step 2 is putting my prime factors into the Venn diagram. As you'll see, I'm only going to move the numbers that have been circled, the prime numbers, not, for example, 10, because that's not a prime number. So we're only taking the prime numbers and putting those in our Venn diagram. So with my Venn diagram, I'm going to have two circles. The left-hand circle is going to contain all the prime factors of 10, and the right hand circle is going to contain all the prime factors of 4, and in the middle will be any prime factors that are of both 10 and 4. 5 is just a prime factor of 10, so I'm just going to put that in the 10 circle and then cross it off, so I know I've done that. 2, well, there's 1 2 in both the 10 and the 4 factor tree, so I'm going to put that 2 in the middle and I'm going to cross it off. Is in the middle because it's both a prime factor of 10 and 4, and I've crossed that off, and I've got 1 2 left, and I'm going to put that 2 just in the 4 circle because the 2 that is in the 10 factor tree is already in the Venn diagram. I've already crossed it off. Now, to find the highest common factor, I'm just going to look at the intersection of the Venn diagram. That's the middle part, the overlapping part. And the highest common factor is all the numbers in that middle part multiplied together. In this case, there's only one number, the number 2. So the highest common factor is just 2. And if we used our other method that we saw at the start of this video, we would have got that as well. To find the lowest common multiple, I multiply all the numbers in the Venn diagram. So I've got a 2, a 2, and a 5 if I list them in ascending order. 2 times 2 times 5 is 20. So my lowest common multiple is 20. And again, I would have found that if I did it in the other way. I'm now going to move on to a longer and slightly trickier example, but the steps are exactly the same. So just as before, I'm going to break down each number into its prime factors, and they're there on the left-hand side again. In this one, I'm looking for the lowest common multiple and the highest common factor of 48 and 72. So 48 I know is an even number, so I'm going to split that into 2, and I know that 2 times 24 gives me 48. 24 is still an even number, so I can split another 2 off there, and 2 times 12 will give me 24. 12 I can split into 2 and 6, and 6 I can split into 2 and 3. I'm now going to go through and circle all the prime numbers. This is more helpful with this one than the previous one because there are more numbers that aren't prime factors. Also notice that the prime factors are the end of each branch. Now let's split 72 down. 72 is an even number, so I'm going to divide it by 2 and I get 36. Then I can split 36 into 2 and 18, I can split 18 into 2 and 9, and I can split 9 into 3 and 3. Again, I'm going to go through and circle all those prime factors. And as a product of its prime numbers, 48 could be written as 2 times 2 times 2 times 2 times 3, and 72 could be written as 2 times 2 times 2 times 3 times 3. Step 2 is to place the prime factors in the Venn diagram. So I'm going to do that now, and I'm going to cross them off as I go. There's 1 2 that's in both, so I'm going to put that in the middle and cross it off on both sides. There's another 2 that's in both, so I'm going to put that in the middle and cross it off, and a third 2 that's in both. There's a fourth 2 for the 48, but not for the 72, so that's just going to go in the 48 circle, and I'm going to cross it off. There's 1 3 that's just in the 72, so I'm going to put that in and cross that off, and then there's 1 3 that's in both, so that's going to go in the middle, and then I'm going to cross that off. I've now listed all my prime factors, so I'm finished with that step. Now, to find the highest common factor, just as before, I multiply together all the numbers that are in the intersection, this part shown in red, so that's 2 times 2 times 2 times 3, and that will give me 24. So the highest common factor of 48 and 72 is 24. You could have found this out using the T method, again, as I showed at the start of this video, but that may have taken longer and you're more likely to make a mistake there. To find the lowest common multiple, I multiply all the numbers that are in my Venn diagram. They're in either circle and the intersection. So that's 2 times 2 times 2 times 2 times 3 times 3. And altogether, that gives me 144. You could have worked that out by listing the multiples of 72, but that requires knowing your 72 and 48 times table, or going through and working that out. And we didn't need to do that with this method. One more example, and in this case, we're using slightly bigger numbers, but again, the steps are exactly the same. I'm finding the lowest common multiple and highest common factor of 140 and 330. 140 I know is even, so I'm going to split it into a 2 and a 70. 70 I can split into 2 and 35. 35, that's in my 5 times table, so that can be split into 5 and 7. I'm going to put a ring around all the ones that are prime numbers. Those are the ones at the end of each branch as well. And I'm checking that off with my list on the left-hand side. So 330, this time it makes more sense to me to split it into 3 and 110. 110, that's even, so I'm going to split that into 2 and 55. and 55 is in my 5 times table, I'm going to split that into 5 and 11. So I can write 140 as 2 times 2 times 5 times 7, and I can write 330 as 2 times 3 times 5 times 11. I'm now going to put all my prime factors in a Venn diagram. I'm going to put that 2 on the left-hand side and that 3 on the right-hand side. That 2 is in both, so I'm going to put it in the middle. There's a 5 in both, so that's also going to go in the middle. There's a 7 just in the left-hand side, so that's going to go just in the 140, and there's an 11 just on the right-hand side, so that's just going to go in the 330 circle. Now, as with all the previous steps, to find the highest common factor, I multiply together all the numbers that are in the intersection. So here that's 2 times 5, which gives me 10. And also to find the lowest common multiple, I can go through and multiply all the numbers that are in my Venn diagram. So this is 2 times 2 times 3 times 5 times 7 times 11, which is 4,620. And that is the lowest common multiple of 140 and 330. Notice that whenever I'm listing my prime factors, I'm always doing them in ascending order, so from the smallest to the biggest. I just want to end by showing you something about factor trees. As you were thinking about the factor trees that I was drawing, you might have thought about a different way that you could do it, a different way you could split up each number. And that's perfectly okay, and you can do that, and you will get exactly the same prime factors. That's what's interesting about factor trees, and just demonstrates something about numbers themselves. 140 is made up of the same prime factors regardless of how you split it down, and I'm just going to demonstrate that with 2 different factor trees here. So let's take 140, and one way you could do it is splitting it into 2 and 70. Then you could split 70 into 2 and 35, and 35 down into 5 and 7. This is the way that I did it in the previous example. I'm then going to circle 2 and 2 and 5 and 7 because those are all my prime factors. So I could write 140 is equal to 2 times 2 times 5 times 7. Now, perhaps when you saw that, you wanted to do it a different way. You wanted to split 140 into 10 and 14. You can do it that way. Then you've got to split each part down differently again. 10 can be split into 2 and 5, and 14 can be split into 2 and 7. Now, if you look at those numbers that have been circled, they are exactly the same as the numbers that have been circled on the left-hand side. The other numbers are different, but we don't actually care about those other numbers. We only care about the prime factors. And as you'll see, 140 is still 2 times 2 times 5 times 7. No matter how you break it down, you'll always get those prime factors. I hope this video has been useful. As always, you can comment if there are other topics you'd like me to cover specifically, and I can make a video on those. Thanks, guys.